Section 7.2a, Systems of Linear Equations. Same type of thing we dealt with in section 7.1. They separated substitution and elimination. I don't care what method you use, so we did everything together in 7.1. So basically 7.2 is just going to give you another couple of days here to understand more clearly what we were doing if you don't. In this case, first system here, set up very nicely for elimination. Add straight down, we get 8x. 2y minus 2y is gone. 4 plus 8 is 12. Divide, and we get x to be 3/2. Once we know what x is, take either equation and solve for y. I'm going to use the top equation. 3 times x, or 3 times 3/2, plus 2y equals 4. Simplify. 9/2 plus 2y equals 4. Subtract the 9/2 over. Divide by 2. And we get y to be negative 1/4. So our ordered pair is the ordered pair 3/2, negative 1/4. Number 2. If you want to use substitution here, go ahead and use substitution. I'm going to use elimination. I'm going to eliminate y's, which means I need to multiply this bottom equation by 3. When we do that, we get 9x plus 3y equals negative 15. Top equation I'm going to leave alone. 2x minus 3y equals negative 7. And add them up. We get 11x equals negative 7 minus 15 is negative 22. Divide by 11. We get x to be negative 2. Once we know what x is, plug back in and find y. I'm going to use this bottom equation. 3 times x plus y equals negative 5. Add the 6 over. We get y to be 1. So our ordered pair is negative 2, 1. Number 3. I'm going to use elimination once again. If we eliminate y's, that means I need to multiply the top equation by 4. We get 20x plus 12y equals 36. Bottom equation I need to multiply by 3. We get 6x minus 12y equals 42. Now if we add those two equations together, 20x plus 6x, 12y minus 12y is eliminated, which is what we want. Divide by 26, we get x to be 3. Once we know what x is, use either one of the two equations again to find y. So we have 2 times x minus 4y equals 14. Subtract the 6 over. Divide by negative 4. We have the ordered pair 3, negative 2. Number 4. Once again, I'm going to choose to use elimination here. If I'm going to eliminate x's, I multiply this top equation by 2. We get 2x minus 4y equals 6. Bottom equation I can leave how it is. Add them up. 2x minus 2x is gone. Negative 4y plus 4y is gone. We're left with nothing. 6 plus 1 is 7. Anytime the variable stuff drops out, you're left with one of two situations. Either you have infinitely many solutions or you have no solutions. In this case, does 0 equal 7? No. So there is no solution to this system, meaning that these two equations will never intersect if we were to look at their graphs. Number 5. Once again, I'm going to use elimination. This time I'm going to multiply the top equation, if I'm going to eliminate x's, by negative 2. We get negative 4x plus 2y equals negative 2. Bottom equation I leave alone. Add them up. X's are eliminated. Y's are eliminated. So again, I have nothing on that side. Negative 2 plus 2 is eliminated. 0 equals 0 to 0 equals 0. Yes, when does that happen? All the time. Therefore, we have infinitely many solutions. Okay, last one here, number 6. If you have fractions in your equations, if you have decimals in your equations, first thing I would do is multiply to get rid of the fractions or decimals. In this case, I'm going to multiply everything by 100. So I'm left with 2x minus 5y equals negative 38. Same thing in the second equation. I'm left with 3x plus 4y equals 104. Using elimination here, if we want to get rid of the y's, we're going to multiply the top equation by 4. So when I do that, I get 8x minus 20y equals negative 152. Bottom equation, I'm going to multiply by 5. When I do that, I get 15x plus 20y equals 520. Add them up. 8x plus 15x is 23x. Y's are eliminated. Negative 152 plus 520 is 368. Divide by 23, we get x to be 16. Once we know what x is, plug in anywhere you want to find y. If I use this bottom equation here, actually I'm going to use the top one. Let's go 2 times x, which we now know is 16, minus 5y equals negative 38. 32 minus 5y equals negative 38. Subtract the 32 over. Divide by negative 5, and we get y to be 14. So we have the ordered pair 16, 14 is the intersection point between those two lines.